Welcome to this tutorial on the Kotlin Type System. Today, we'll explore one of Kotlin's most powerful features, how it combines static typing with type inference to make your code both safe and clean. Let's dive in. First, let's understand what static typing means. In a statically typed language, types are checked at compile time before your program even runs. This is incredibly beneficial because it catches type errors early in the development process, preventing potential runtime crashes. Think of it as having a safety net that validates your code before it reaches production. Traditionally, in statically typed languages, you need to explicitly declare the type of every variable. For example, when declaring a variable called name, you specify it's a string. When declaring age, you specify it's an int. Similarly, version is declared as a double and isOSM as a Boolean. While this approach is clear and explicit, it can lead to verbose code with a lot of repetitive type annotations. Here's where Kotlin's type inference comes in. You can write the exact same code without explicitly declaring the types. The compiler is smart enough to figure out that name is a string because you assigned it a text value. Similarly, it infers that age is an int from the number 42. Version is a double from 1.9, and isOSM is a Boolean from the value true. This makes your code significantly cleaner and easier to read. So how does type inference actually work? The Kotlin compiler analyzes the value you assign to a variable and determines its type automatically. But here's the crucial part. Even though you're not writing the type explicitly, type safety is still fully maintained. Kotlin doesn't become a dynamically typed language just because you omit type declarations. The compiler still enforces strict type rules behind the scenes. Let's see type inference in action. When you declare a variable called number and assign it the value 42, Kotlin infers its type as int. Now, once that type is inferred, it's locked in. If you try to reassign the variable to a string value like text, the compiler will throw an error. It will tell you there's a type mismatch because a string cannot be assigned to an int variable. This demonstrates that type inference doesn't compromise type safety whatsoever. While type inference is convenient, there are situations where explicit types are still required. The most common case is when declaring function return types. When you create a function like calculateTotal that takes a price parameter, you must explicitly specify that it returns a double. Similarly, the getMessage function must declare that it returns a string. This explicit declaration makes function contracts clear and improves code readability, especially in public APIs. Let's recap the key points. First, Kotlin is a statically typed language with compile time type checking, which means errors are caught early. Second, type inference reduces boilerplate code while maintaining complete type safety. And finally, Kotlin gives you the best of both worlds, the safety and reliability of static typing combined with the convenience and cleanliness of type inference. This balance makes Kotlin both powerful and pleasant to work with.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.